Hi all, today we are going to discuss a small topic in the subject Computer Aided Design and Analysis. We are discussing 5th module and it is the first part of my presentation. Today's topic is stiffness matrix and load vector for a linear element or one-dimensional element. First of all, we must know what is stiffness. Stiffness is a property of an object to resist deformation in response to an applied force. In order to get an expression for stiffness in finite element method, we must review strain energy equation or expression given in our mechanics of solid classes. First of all, we are giving an expression that K is equal to integral B transpose D into B into dV. It is the expression for element stiffness matrix, and we must know what is B, D and dV, where dV is the change in volume, or it can be expressed as A into dx, area of cross section into dx, and B is the relationship between strain and displacement, and D is the relationship between stress and strain. We must differentiate what is B and D. It is strain and displacement, and it is stress and strain. Stress strain relationship already known as Young's modulus in one-dimensional problem, or it can be expressed as E or Young's modulus. And B is the strain displacement relationship, and it can be defined for one-dimensional element as one-dimensional linear element as B is equal to dn1 by dx and dn2 by dx. It is the derivative of shape function, and we have already known the strain is the change in length and ratio of change in length and original length, and in finite element it can be defined as E is equal to du by dx, where u is the displacement function. For formulation of stiffness matrix of a linear bar element, first of all we must consider a figure given below as nodes 1 and 2 at two ends and displacement u1 and u2 respectively, and L will be the length of bar element, and nodal displacement or degree of freedom, it can be defined as degree of freedom in two node elements or one dimensional elements, and it can be defined as u1 and u2. And shape function we have already derived in our previous presentation, and n1 and n2 are given as 1 minus x by L and x by L. When we are thinking about strain, which is du by dx, we must find B matrix, which is the derivative of shape function dn1 by dx and dn2 by dx. We have n1 and n2 here, and we can find dn1 by dx and dn2 by dx as minus 1 by L and 1 by L, and finally B will be matrix minus 1 by L and 1 by L. And for finding element stiffness matrix, which is the equation is given as B transpose D into B into A dx, which is dV. dV is replaced with A into dx, and D can be replaced with E, and we have found B for one dimensional element as minus 1 by L and 1 by L, and B transpose will be transposes this matrix. And finally, rearranging this in the above equation, we can find it as B transpose into B into D matrix is replaced by Young's modulus E, and dV is replaced by A into dx, and when integrating dx will become length L, and final equation will be like this. And when multiplying matrix B transpose and B, we will get it as EAL into 1 by L square minus 1 by L square minus 1 by L square 1 by L square, and when taking L square outside we will get the equation as like this. And final equation for stiffness as K is equal to EA by L into 1 minus 1 minus 1 1. It is the final equation for stiffness matrix of linear element in one dimensional problem. And now we are going to formulate load vector for a linear bar finite element. We are taking a self-weighted hanging bar as shown in the figure. You can see the figure, and there is having that element having a weight of W, and load vector is given by integral n transpose into W, where n transpose is the transpose of shape function. We must consider following factors, that is, it should be a vertically hanging bar with length L, uniform cross section, the area of cross section should be A, density of the material should be rho, and Young's modulus as E, and it is also having a self weight of W because of gravity. And load vector can be written as integral of n transpose into W. First of all, we must find the self weight equation W. W is equal to rho into A into dx or rho into dv. That equation is extended as rho into A into dx, which is commonly used equation in mechanics of solids. Shape function is given by n1 and n2. The equation already known to us. N1 is 1 minus x by L and N2 is x by L, and hence the transpose of n will be 1 minus x by L and x by L in column matrix. And we can write the final equation as for force vector as integral n transpose into W, or n transpose is 1 minus x by L and x by L, and W as rho A dx. We can take rho and A outside of the integral because they are constant, and when integrating we will get the final equation as rho into A into 1 minus L square by 2L, L square by 2L, and again replacing we will get the equation as 1 minus L by 2 and L by 2. L square and L get cancelled, and L square and L get cancelled in both sides. And when we are subtracting L by 2 from 1, that will be L by 2, and final equation will be rho A L by 2 into 1 1. This is the final equation for load vector. We must give importance while studying stiffness matrix and load vector in a bar element. It is regularly asking question in KTU. Thank you.